Welcome to Sencore's technical training, Tech Tape, on understanding television horizontal output stages. This video presentation will help you better understand how television horizontal circuits work, how they fail, and how they interconnect with other stages in the television receiver. This tape is divided into the sections shown here. Each section is indexed so you can quickly locate the one you need. A television receiver's horizontal circuits are the most complex and hardest working of any in the receiver. This is why defects in the horizontal circuits are common and account for many television receiver failures. The horizontal output section performs two major functions. First, it is responsible for producing deflection current in the horizontal yoke that moves the CRT's electron beam from side to side. Secondly, the horizontal section produces flyback currents. These currents produce high voltage and scan rectified voltages and control or keying pulses, blanking pulses, and pincushion correction voltages. A television receiver's horizontal section has five main functional stages: horizontal oscillator, horizontal driver, horizontal output, high voltage multiplier, and automatic frequency control. Let's briefly review the function of each before we cover them in more detail. The drive signal for the horizontal output section originates in the horizontal oscillator. The oscillator generates a 15,734 Hertz waveform. The horizontal driver stage buffers the oscillator's output to prevent loading and provides sufficient drive current to the horizontal output transistor. The horizontal output stage is energized by the drive signal. The drive switches the output transistor on and off, which in turn produces alternating currents in the flyback and yoke. High voltage pulses from the flyback transformer's secondary feed the high voltage multiplier. The multiplier rectifies the pulses and steps up the voltage to produce 15 to 30,000 volts for the CRT second anode. The multiplier also provides CRT focus and screen voltages. The automatic frequency control stage compares the phase of the horizontal sync pulses to the flyback pulses. The AFC sends a DC correction voltage to the horizontal oscillator to maintain the correct frequency and phase. The horizontal oscillator generates a 15,734 Hertz drive waveform. Horizontal oscillators in today's television receivers are usually part of an integrated circuit and are typically an RC type. Components external to the IC are critical to the oscillator's operation. They set the oscillator's free running frequency near the 15,734 Hertz horizontal rate. Some IC oscillators run at 2 times, 16 times, 32 times, or another multiple of the horizontal sync frequency. A frequency divider or countdown circuit within the IC develops the normal 15,734 Hertz drive output. The AFC circuit locks the oscillator to the incoming sync pulses. Let's take a closer look into the operation of a typical IC horizontal oscillator. The oscillator consists of transistors and resistors in the IC, and an external capacitor and resistor. The output of the oscillator is a sawtooth waveform at the base of Q7 or pin 7. A circuit defect in the horizontal oscillator generally causes one of two symptoms: no high voltage or deflection, or sloping diagonal bars. Circuit defects in the horizontal oscillator may stop it from oscillating. If so, there will be no drive signal to the horizontal driver or output stage. The lack of a drive signal results in no deflection or high voltage. Other defects may cause the horizontal oscillator to run faster or slower than 15,734 Hertz. Sloping diagonal bars that tear up the picture occur if the horizontal oscillator is off frequency. Bars sloping upward indicate the oscillator is running slow, while bars sloping downward indicate the oscillator is running fast. Severe frequency errors may reduce the high voltage and deflection or cause the horizontal output transistor to fail. The horizontal driver stage buffers the oscillator's output and amplifies the oscillator's weak drive signal. Typically, a chassis contains the equivalent of two horizontal driver stages, a pre-driver stage inside the horizontal IC, and an external discrete transistor stage. The IC pre-driver performs two functions. First, it serves as a buffer to prevent oscillator loading. Secondly, it shapes the oscillator's sawtooth waveform into a square wave output. Some horizontal pre-driver ICs include provisions to disable the output drive waveform to achieve high voltage shutdown protection. The square wave drive signal from the pre-driver IC receives added amplification from the horizontal driver stage. The main components in the horizontal driver stage include a transistor, driver transformer, supply resistor, decoupling capacitor, and an RC network across the driver transformer primary. The driver stage develops the needed base current to drive the horizontal output transistor. The horizontal driver transistor is turned on by the drive signal applied to its base and conducts current through the primary of the driver transformer. The turns ratio of the driver transformer increases the current drive to the base of the output transistor. Defects in the horizontal pre-driver driver stages may cause several symptoms: no high voltage or deflection, reduced high voltage and deflection, or horizontal output transistor heating and failure. A defect in the horizontal driver may result in no output drive to the horizontal output transistor and consequently no deflection or high voltage. A defective driver stage may result in reduced base current drive to the output transistor. With reduced drive, the horizontal output transistor cannot produce the collector current demanded by the flyback and yoke. This starves the flyback and yoke of the required current and reduces the high voltage and deflection. Other problems in the horizontal driver stage may cause subtle defects in the drive signal applied to the output transistor. Such drive defects may cause the horizontal transistor to develop excessive heat because the switching speed is reduced, or cause ringing in the drive waveform that causes erratic switching and sizzling sounds in the flyback. Either defect usually leads to destruction of the horizontal output transistor. The horizontal output stage produces alternating currents in the flyback and yoke. The yoke current provides horizontal electron beam deflection. The flyback current generates the high voltage and produces scan-derived voltages and horizontal keying pulses. The horizontal output stage has 6 key components: a horizontal output transistor, flyback transformer, retrace timing capacitor or safety cap, damper diode, yoke and yoke series capacitor. The horizontal output transistor is a power transistor. It must conduct high levels of peak inductive currents and withstand high voltage pulses. Because it functions with high current and voltage levels, it is a high failure component. The operation of the horizontal output transistor is best compared to a fast switch. The transistor is switched on and off 15,734 times a second by the signal applied to its base. When the transistor is on, the emitter to collector resistance is only a couple of ohms. The amount of current that flows through the transistor is determined by the inductance of the flyback and yoke. The current reaches a peak of several amps before the transistor is switched off by the drive signal. The flyback transformer is responsible for developing high